for this lesson, we have here our third lesson for the fourth quarter. So it's going to be about tangents of circles. And this is going to be an entire topic all about tangents. And also we're going to be discussing the other segments involved with a circle. So that includes the secant and the chords. But for this one, we're going to be starting with tangents of circles. So let's have our first problem over here. Andreas, for his rural maintenance project in his landscape architecture course, wanted to build a park in the rural center of their community. A fountain display is inscribed in the triangular park, as shown below. So given that the three sides of the triangular parks are tangents, okay, that's your clue word here, tangents at circle O, what is the perimeter of the park? Okay, so we have a theorem, guys. We have a theorem about tangent lines. If we have an external point, okay, and they have two tangent lines, let's say for example, these are the tangent lines that we have here, okay, for this one. Therefore, this external points QA is going to be equal to QC for this one. So therefore, we can say that QA is equal to QC, and therefore QC is equal to 6. And we also have another set of tangent points for this one. We can say that AP is equal to BP, and since we know that AP is equal to 12, therefore BP must be equal to 12 feet. Okay, for that one. And then we also have another one for this one. So we have your CR. Okay, point C and R are going to be equal to, okay, the segment CR is going to be equal to RB. And since RB is equal to 9.5 feet, therefore CR, okay, so RB is equal to CR, which is equal to 9.5 feet. And therefore, we can now solve for the perimeter of our given triangular landscape fountain problem. Okay, so for this one, this should give us perimeter is equal to, okay, QP plus RP plus QR. And since we know that QP is equal to 6 plus 12, we can add that. And then RP is equal to 9.5 plus 12. And QR is equal to 6 plus 9.5. We can add all of these. So what's 6 plus 6? So that should give us 12. 12 plus 12, that should give us 24. And 9.5 plus 9.5, so that should give us 19. Okay. And what's 12 plus 24 plus 19, guys? Okay, so let's try to compute that. So that's going to give us 12 plus 24 plus 19. So that should give us 55. Okay, 55. Okay, so that should give us 55 feet. Okay, therefore, this is the perimeter of the triangular, part, okay, with the tangents there. Okay, so that's going to be 55 feet. And that's how we solve this problem.